Question 9, prove or disprove. A necessary condition for an integer to be divisible by 6 is that it be divisible by 3. So just to restate this as an if-then would make it easier to prove or disprove. So this says that if an integer is divisible by 6, then it is divisible by 3. All right, so if I want to prove this, I can suppose the if part. Suppose n is an integer that's divisible by 6. So I've supposed the if part of my statement. I need to show that n is divisible by 3. I need to show the then part. Okay, so if it's divisible by 6, then n is a multiple of 6. That's what it means to be divisible by 6 for some k and z. Thus, n, which can be written as 6k, can be rewritten as 3 times 2k, and 2k is an integer. Since 2k is an integer, n is a multiple of 3 and thus is divisible by 3. Number 10, prove or disprove. For all integers a, b, and c, if a is a factor of c and b is a factor of c, then a times b is a factor of c. So let's start with some tests. A, b, and c are all integers, and a is a factor of c and b is a factor of c, then a times b is a factor of c. So let's see, something that has a lot of factors could be like 12. So let's say c is 12. Okay. So a and b have to both be factors of c. So a could be 4 and b could be 3, right? Those are both factors of c. And is a times b a factor of c? Yeah. AB, which is 12, is a factor of c. Okay, so there's one test that worked. Let's use the same c and different factors because it has a lot of factors, right? So let's have a be 6 and b be 2. So those are both factors of 12. A times b is 12 is a factor of c. Okay, so we've nearly exhausted all the factors of 12, right? There's one more set. So we'll let c be 12 and we'll let a be 12 and b be 1. All right, so we have 4, 3, 6, 2, 12, and 1. Those are all the factors of 12, right? Okay, so a is a factor of c, b is a factor of c, a times b is a factor of c. So that one works. Times 1 is a factor of c. Okay, now a and b don't have to multiply together to make c, though. So I think that I'm overlooking some possibilities here. Like, I've been choosing factors that multiply together to make c, 4 and 3, 6 and 2, 12 and 1. But they don't have to be factors that multiply to 12. Like, I could use 4 and 6. Like, if I do c equals 12, right? A could be 4 and b could be 6, right? 4 is a factor of 12. Oops. 6 is a factor of 12. So I've satisfied the if part. A and B are both factors of C, but 4 times 6, which is 24, is not a factor of 12. Okay, so we found a counterexample, and this is not always true.